O'Gorman. He's a data industry veteran of over 30 years of experience in all things data. He's also a CEO of Semantium, a startup dedicated to the idea that quality business language is the key to good business decisions. Okay, thank you.
Thank you. All right, thanks everybody for coming, and I want to thank the YYC Data Society for having me here today. As I was, everybody's talking about data these days. I was walking from the train to the library here today. There was a guy standing on a street corner with a hat on the ground, and he was saying something like, "Now is the AI winter of our discontent. Make glorious summer by this chat GPT. And all the cloud services that lowered upon our warehouse in the deep bosom of the data lake buried." Say, wow, man, poetic and topical. $5 to you. So today we're going to talk about how this connection between the business and data and decisions are made using something called faceted classification. And we're going to borrow something from a number of different industries. So here we go. So thought for the day, if we're ever going to make large data work, we really have to prove to business that we can make small data work. The smaller the data, the better. If you look at the principles of FAIR, findable, accessible, interoperable, which is a really key one, and reusable, the smaller the piece of data, the easier it is to reuse, and you should make it findable so you can reuse it. So here's what we're dealing with. Here's the problem in one slide. So the business understanding is I have a product. The product has a name, it has a number, it has a barcode. The metadata values, that red arrow, is where we have silos starting. So we have 3 different applications. I'll tell you what the acronyms mean in a minute. This is one of my pet peeves about some going to a new business. But so it's supply chain management system, the inventory management system, and the warehouse management system. And we're going to tie all this into a grocery store metaphor. That's where the problems start, because the business has a relatively easy and simple understanding of what this means. The tech guys and then the database designers, not so much. So product names, all of the attribute names are different, the metadata values are different, the product number metadata values are different, and the barcode numbers are different. And then it gets really interesting because the instance data is also different. So you've got this huge amount of divergence when it comes to in making things interoperable. So Dave McComb talks about a data-centric revolution, and we're talking today a little bit about a small data revolution. So IT spend is way out of balance in the middle. So if you look at it as a supply chain, on the upstream you have language and data. In the midstream you've got analytics and all of these heavily technology centric kind of cost centers. But according to a Talent poll, Talent being the software company, 65% of executives in 2022 do not trust the decisions they make on their data, do not trust their data. So to correct this, Zama came up with this idea of a data mesh and data products. Part of the problem is that she does not have, and this was brought to me secondhand from Joe Reese, who's on LinkedIn a lot, she does not have a way of semantically connecting the products. So the idea is that individual organizations in the business will create their own data products for consumption on analytics, but there isn't any way to tie, say, finance products to sales products. So again, the products are siloed. So we have to start investing upstream. So finding and accessing and connecting and leveraging data should be as easy as shopping for groceries. So we're going to use the grocery store metaphor, but we're also going to take a look at this cost of quality rule. So this is Benjamin Franklin's an ounce of prevention is worth a pound of cure. And so $1 prevention, $10 remediation, $100, and I'm using just small numbers because everybody knows that the cost of remediation on some software projects is enormous. So here's the different spin on it. So the upstream is going to be an investment, the midstream is a cost, and the downstream is value. This is what it looks like right now. So this is the imbalance. The current state on things like data governance and data quality is quite small. The midstream cost is enormous. It's very large. Somebody said that the worldwide spend on IT in 2021 was over $4 trillion, and 40% of that was data wrangling. or keep cleaning up messes. That's a significant number. In spite of that huge investment, on the downstream side, on the decision side, we have this low value. So this is what we're proposing. We're going to change the balance. We're going to increase our investment upstream. We're going to lower that cost in the midstream, and we're going to get better decisions at the end. That's the objective. And I'll show you some ideas about how to get that done. Not like this. It's really, really difficult, as most of you in the data field know, to get business to think holistically about data. It's all about those seagulls and Finding Nemo. Mine, 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 mine. Right? So this is the push. This is the big tech push. And by the way, they do this every year in Japan, where these big sumo guys wrestle little kids. And if you go online and look at the pictures, it's like crazy. Okay, so here's the problem, though. On the left is the top technology initiative. This is what tech executives are saying they want to do next year. And this happens to be from 2022 via Flexera. The one on the right is the complaints that IT decision makers have about getting things done. So anybody notice? The biggest pain point is lack of good data. The smallest investment, data governance and data quality. Come on, guys, that's a problem. So how do we fix it? So first of all, we're going to borrow something from geometry. This is a tetrahedron. The idea here is that the points on the outside contribute to the growth and the improvement in the middle. We were using an acronym. Everybody has acronyms. I was going to put a can of cola there, and I thought, oh, what the heck. So classification, optimization, labeling, and architecture. Those are the 4 things that we're going to focus on. We're going to build something, and we saw a reference to, my goodness, woo! So we saw a reference to this in the previous, in Trudy's presentation, which was awesome. I think she set a land speed record for PowerPoint. Yeah. So FAIR means findable, accessible, interoperable, and reusable. That came from a scientific papers notation that said we should all aspire to these things. And then we're going to bet on something. So this is alliterative, borrow, build, and bet on something that already works. And what works is barcodes. Now, we're not going to put barcodes on data. That's ridiculous. We're going to do something similar. But barcodes have been in commercial use since 1974. Does anybody know what the first item was scanned in a barcode? It was Wrigley's. It was a 10-pack of Wrigley's Juicy Fruit gum. So we're going to use a grocery store. Kudos to you, sir. So the grocery store metaphor, classification. This is our C port. You can see that highlighted up there. Narrow classification means I have a raw perishable like a tomato, I have reconstituted tomatoes, and I have repurposed tomatoes. Everywhere that goes, the tomato is identifiable. So we're using something called a digital object ID that once tagged a piece of information, however small, a word like customer, not the tables, not the documents, a word like customer, everywhere it travels is identifiable and findable by its identifier. So that's narrow classification. Broad classification, we see this all the time in grocery stores. So we have dairy, we have bakery goods, we have produce, proteins, and then we have these other sort of random kind of classifications. We have dry goods like cereals and condiments, etc. We have packaging, and we even have down in the lower right there, we have country of origin. So those are all facets, if you will, of classification in a grocery store. In our model, architecture is a manifestation of classification. So when you go in a grocery store, the reason it's architected this way is because the data or the products that you need to take care of on a regular basis are on the outside of the store. And in some cases behind the glass. So the butcher part is behind the glass, and then it's cooler. There's also a separation between storage and retail. So that's important for things like security, right? So customers can't go to the back of the store and start messing around with dry storage, etc. And then all of the aisles contain classes, categories, if you will, of product. So when somebody says, I had a great experience the other day looking for coffee. So I buy Kicking Horse coffee, and they said, go to the coffee aisle. I was like, where's Kicking Horse, Kicking Horse, Kicking Horse? So, you go, okay. So I almost wish that grocery items had RFID tags. You just go on your phone and say, oh, okay, there's the grocery. So I asked the guy, where's the Kicking Horse coffee? Oh, it's in the organic aisle. All right, So anyways, but the general idea is they're classified, the architecture is a manifestation classification. So labeling, this is the other part of the COLA. We have human readable labeling, like metadata, what's in the thing, components, that kind of thing. We have lineage, it comes from the Campbell Soup Company. The brand is Campbell's, what's in the can is tomato soup. And then metrics, that little tiny thing on the bottom is like, what does it weigh? And then you have a cost as well. The thing we're interested in this case, along with the classification, is that little barcode. So those barcodes are now 50 years old almost next year. And the barcode is the bridge to the digital twin. They were originally invented to help throughput for customers. But what organizations found is when they started getting computers involved, of course, with the barcode you have to have a computer, but they were standalone. But now you can do things like supply chain, logistics, sales. You can change the price like in an instant, and the price is reflected at the till, right? You can look at sales, competitors, all of those types of really cool information management things come to the fore just on that one thing. So keep that in mind while we do the faceted classification part. A facet, technical definition of a facet is a mutually exclusive, collectively exhaustive category. All that means is I have person facet. I can't put a physical asset in there. I can't put a thing in the person facet. People, places, things are the traditional entity facets. Semantium goes a bit further because it's a language-based model and says that we also need to classify things like events, states, dates, activities, and functions. So that's a lot, but it covers the whole gamut of business language, right? So when a business person says a word like procurement, that's a process. That's a process word. And if he wants to, if a business user wants to, he can type in procurement into the Semantium graph and see how that word is connected to tasks and process and documents and data and analytics. All from that one, it's like pulling a thread. So the collections tend to be small and inclusive, as I just mentioned, and the facets are technology agnostic, language neutral, and domain independent. So what that means is these facets, there's 19 of them in our model, and you see them on the right are based on Rudyard Kipling's 6 Honest Servicemen. The who, what, when, where, why, and how. They teach me everything I need to know. The other part of that poem says, without these, you just have one great big mess. Sound familiar, right? So the other thing that you need to know about these facets, and this model kind of came from, I was doing business analytics in 1988, and we're using a program, most of you won't know this one, but SPSS. It's a statistical software. So we ran all of the operational databases through SPSS, and what started to come out was these 19 dimensions. So this was for a university. So we had people, we had places, we had activities, all that kind of stuff. And then the interesting thing about it was, one of the problems that they were having was sometimes instructors, especially sessionals, would fill more than one role. So they could be an instructor, they could be taking a course, they could be on a committee, they could be on the board of directors. And when they did counts of how many people in the business, they kept double counting because the people were bound to the roles. So this technique is called separation of concerns. So for example, if I have a position called chemical engineer available in my company, I can describe the whole role, responsibilities, who you're reporting to, the cost and everything, hold that down as a role, and leave the node for the person filling that role empty. So it's that data, that collection of data persists because that's important to me to manage that separately. Once I put a person in that node and connect them, say that this person has that role, right? Now I can start to do a whole bunch of really interesting things because that person might have another role. So that's the faceted classification part. The data-centric part, and I strongly recommend anybody in the data, especially for students and people who have been sort of application-focused, technology-focused. Dave's written 2 books, actually 3. The first one was written quite a while ago. The second one is called Data-Centric Revolution, and it's basically the premise there is that rather than having all of these silos of applications, all of these data siloed in applications, we put the data in the middle, in a hub, in the center, And we basically create applications that subscribe through services to the data that's common to the business. The data in the middle in our model is very granular, extremely granular. In fact, and some people say, well, geez, man, you put that much granular data, it's going to have like terabytes of little tiny pieces. That's not the case. In Dave's experience, most companies have less than 100 concepts that they use to run their whole business. The number of data points obviously depends on the volume of transactions, but the classes are fixed at 19, and the way that he organizes his data is like this. The core has, we call this the Semantium core. The core has 3 levels. The levels are not facets because they're not mutually exclusive, but it's all dependent on the business, but we'll leave that aside for now. The semantics are in the middle. The metadata that connects to the semantics. So the semantics is the business language. And it can be in any language. It can be in English, it could be French, it could be Arabic, it could be any of those languages that your business needs to manage, which is important. The metadata that supports those business concepts is around the outside of the core. So, and then the final, the instance data, and again, Jon O'Gorman's an instance data, that's it. There's no connection between me and anything else in the core. So do I have a Jon O'Gorman? Yes. Do I know what he does? That depends on whether you can access some of these satellite applications. This is sort of future state. But you can create sort of a working and evolving model for businesses by simply saying, okay, we have facets, we have identities, and we have this way of organizing things. So one of the immediate advantages, 2 actually immediate advantages, use case, if you're a rookie, if you're a newbie coming into a job and you don't know what the acronyms OOHA means, UHA, anybody want to, no? If your boss comes in and says your job depends on knowing what that acronym means, you better find out. All right, okay, so go into Semantium, type in OOHA, it stands for out of home advertising. Who knew? Not me, I didn't know that until yesterday. So, but then the thing is you can connect that simple thing in the center, semantics, to one of the applications and say, okay, how much advertising, where is it placed, how much did it cost us, who are we advertising for, that kind of thing. So this is kind of a future state architecture. Now we come back to the barcode. Semantium uses a single set of attributes, there's 12 of them, one of which happens to be the quant class, and a quant is simply an atomic piece of information. Atomic doesn't necessarily mean small. If I have a resume, resume.2023 or something, that's a quant. It's a name of something bigger. But if I don't have access to the content store, I can't see it, but that's beside the point. So these attributes are the labeling standard that we use throughout. Every single node, and we're using knowledge graphs as our platform. Right now we're using Neo4j. Every single node has exactly the same attributes. The reason is because the language drives where that attribute, or where that node shows up, in which category. The language drives how that node is connected to everything. And so you have a simple, almost like a universal product code for data. That's the premise, that's the idea here. So this is what it looks like when you're solving the small data challenges first. One of the most important things is, and this came up a couple of times in Trudy's presentation and the data quality guy, I might have a number of definitions for the word invoice or the concept of an invoice date. So the concept of where that invoice date definition comes from needs to be managed in the provenance, the source. So if I'm having a conversation with the fellow in the jacket here at the front, and I say invoice date is blah blah blah, and he's saying what's your lineage on that, we can have a discussion about, oh, it's an ISO 86 whatever standard, or we can say it's not. So the reason that we do that, the lineage is part of that, and also with the language, is that so we can sort of get some sense of equivalence. They're not identical, but they're semantically equivalent. So on the slide here, for example, you've got the acronym SKU that stands for stock keeping unit, and then you have a definition. So the acronym, the phrase, and the definition are connected by an edge that says this is equivalent to that is equivalent to that. You can use this equivalence, and I'll just focus on this as an example. You can use this equivalence to manage multiple language, multilingual translations of documents, multilingual databases, or you can use it to expand acronyms, something simple like that. So, so this is basically solving that problem that we saw in the second slide, where you've got different metadata values, different instance values, and this is tying it all together. So the other thing, to borrow a phrase from an Academy Award winner, so everything all at once. So this view, we have an MVP out now that we're going to demo at 1 o'clock. Actually, it's going to be an interactive demo, kind of a combination of wiki, page, and bumper cars, because we'll have lots of collisions on the graph, but we'll have, it's a participatory thing, so bring your laptops and we'll show you how it works. One of our MVP testers is in the mergers and acquisitions business on the advertising vertical. She uses this to see in her acquisition targets or her acquisition databases how to connect her existing metadata to their metadata. Her new hires use this to, as I mentioned, to find acronyms and abbreviations and codes that are embedded in the data, and then to drill into how that business language, how those instances of business language are connected to metadata and how they're connected to instance data. So she sees all three layers in the core all at once. So if somebody phones her up and says, "Hey, Brandy, we have an issue in da-da-da-da-da," or whatever, or we're seeing this disconnect, how do you see it from Semantium's perspective? And she can see all of this all at once. And it's really very effective. It's very simple interface so far. MVPs, as you know, are kind of like riding a bicycle with lumpy wheels. It's like, oh shit, but the fact that somebody's using it to do, like, it sort of reminds me a little bit of God, I'm getting old. The first cell phone weighed 5 pounds. The charge time on the phone was 10 hours. And the range of use was only 30 minutes. And there was no movies, nothing like that. It was just, it would look like a radio phone. It was literally this big. That's what our MVP looks like. But when people start telling us they're using it for M&A type stuff, that's big, that's huge. So that's a recommendation. So the other thing that the Barcode supports and the Faceted classification supports is for multiple data initiatives. Data quality is one of them. You can see your quality of data right away. Provenance, as Trudy mentioned, and I believe the presenter on the data quality mentioned as well. Persistence, once I connect something like an acronym to an expansion to a definition, it's persistent. You don't have to touch it again. You can reuse it immediately. It's like, again, all I want from the grocery store is a single tomato. How I use a tomato when I get home is entirely up to me, right? Salads, that kind of thing. So product quality, again, we mentioned that. Where used, this is really cool because of the way the facets work, I can look up a value at like prod ID, and I can see the multiple systems that something or its equivalent shows up in, but I can go the other way. I can, because this is a cube, if you imagine a cube, if I start from the person and go to the role, I can get connections, right? I can see how many roles they have, but if I start with the role and go the other way, I can see how many people are sales managers, right? So it's bidirectional, multi-directional. The other one is the master data and reference data. So when I'm putting a product together and I'm using words and nodes and phrases that have been registered in the core, transactions now have these quality components that when you're building a transaction, the components, like we sold ABC, we sold Acme Inc. 40 units of whatever it happens to be, iron ingots or something. So the quality now when you're composing, and the last point is composability, and then multiple representations. This is kind of where this came from, was working at a company in Texas. So they had to translate all of their technical documents into 7 languages, but they had 20 products, 4 product groupings, if you will, and they had to support 3 previous versions, the current version, and then the upcoming version, all at the same time. So that model sort of was born from here to say, if I write a document in French for a technical thing, the French document and the English document start out semantically equivalent, even though they're very large, they've been translated. So keeping track of multiple representations. Shopping for products, decide what you need. We have multiple ways of filtering collections. We have multiple ways of slicing and dicing collections. It behaves just like a business intelligence cube. I just want people, or I just want people connected to an address, or I want people in an address in a role, right? So you can start to see all of these different micrographs kind of popping up. So you search for what you need, you filter it, you check out, and again, this is sort of, if I'm shopping for data in a data analytics sense, I want to know how many people, or where the location of people that bought this product at this store during this time span. So those are 4 classic dimensions of a business intelligence query, right? And then package for downstream. So if I'm the sales department creating a digital product for the company, I can do these 2 steps, package it up, and put it in the warehouse, or in the, let's say in the data product grocery store, and people can find it using these facets. So findability, accessibility. To me, accessibility is not only about security, but it means understandability. So if you understand 2 of the 3 words that someone's using to label a data product, chances are pretty good you're going to be able to use that effectively rather than searching for something or asking Joanne down the hallway, like, where do I find X and X? So the most important takeaways from this talk: all data and information artifacts are valuable. Data as an asset should include business language, is our proposition. Adding more technology without seriously considering your tech stack or your data, opposite way around. Adding complexity with technology, you should think about your data first. In the presentation, the panel we saw with Annette Cooper and her cohort, the question why kept coming up from I think she was a product manager, and her name I can't recall at the moment. Yes, yeah. So she kept saying, ask why, ask the customer, ask the business. That's the first thing you should do. And when the business tells you something, write it down and say, what does product mean to you? What does, that kind of thing. So when you talk about requirements can get down to a single word. What is a customer? What is a product? So semantic graphs are very, very popular right now. The thing that they're missing is the thing that could be their undoing, and it's exactly what's happening in the more traditional data management space. Knowledge graphs create silos. Just by definition, because they're so loosely defined and because they're so flexible, you can put anything in a knowledge graph. This approach to classification, identification, and equivalence means that you have some guardrails, so that, for example, in the M&A space, when company A is joined with company B, and you use these approach, I only need one node to connect those 2 graphs. And that's really, really powerful thing to say, because that's basically you create a linchpin between 2 entirely separate business, entirely separate industries using exactly the same facets and exactly the same identification. So the big news today is we're doing a fully interactive session at 1 o'clock. Nobody in the room and nobody in this data management or in the YYC Data Society knows how this is going to turn out. It could be like a train wreck from the beginning, but so we're going to give it a try. So what we're basically asking you to do, if you have a tablet, well, I don't know if a tablet yet, it's some technology limitations so far, but if you have a laptop, the more the merrier. We're in the discovery room at 1 o'clock. At 1 o'clock, and we look forward to seeing. So thanks for your kind attention. You've been awesome. Thanks very much. Questions? Yes.
This is really interesting. So do you still have your SQL tables, and then this just links how they relate together? So how does this map to your database?
Yeah. So I'm not a real technical guy, so if I get this wrong, don't throw anything at me. But just anybody with tomatoes? No. Okay. So the way this works is sort of a transition. If you want to transition to a fully data-centric graph model, right? There's ways to do that. But in the interim, my partner is in Armenia, and I'd like to thank Mark Nolte, who's my other partner here, working the cameras and stuff. So the short answer is yes, you can connect all of these things into any kind of data store. They don't have to be in a knowledge graph. In fact, if you go back to the diagram where the core, right, all of the liquid stuff, all of the highly granular stuff is in the middle, with provenance and with proper links and stuff, and you can access applications that use SQL databases or Oracle databases. It's technology agnostic. So all you have to have is the connectors, like an ODBC connector, or we use cron jobs to upload and make sure we change things like the metadata values if something's been added or something's been changed. So we use those to scrape the values, or he calls them scrape, but extract the values and just compare them to what we have. So there is a technical way of doing that, but I'm not the right guy. Mark might know, but Mark's relatively new to the company, so.
So Semantium is a company that's providing this metadata infrastructure?
Yeah, so what Semantium provides in addition to the framework is, for example, our business model and our engagement model is to go into a company and help them start with their, so we always start with business vocabulary. It's always the glossary first. And then since we're building in provenance to the glossary, we go from glossary to metadata to instance data. I hope that answers your question. Sort of, yeah, I know. I was talking to somebody about the investment panel, would you hire a generalist? And he thought for a second it was Rob, and then he said, no. He said, if you're a generalist in this environment, you need to hire somebody who knows a hell of a lot more about the technology than you do. And I wasn't offended. I mean, I've heard that before. So that's where Mark and Ruben come in handy. So, yeah. Yes, sir.
Sorry, simple question, but when you mentioned like knowledge graph several times, what do you mean when you're talking about knowledge graph?
Yeah, so a knowledge graph is just a way of there's a whole bunch of different sort of iterations of representations of knowledge graph. The simplest way to describe it is I have this object and I have this object, and I want to connect. I want to make a connection between them. That's it. That's a knowledge graph in a nutshell. That's a graphlet, if you will, right? Google uses knowledge graphs. Amazon uses knowledge graphs. They're a really, really powerful way of surfacing a whole bunch of information in one interface without the overhead of DBMS. But again, because DBMS is mature, but we're still, it's kind of like the accounting dude that was in here before. Accounting is the second oldest profession on the planet. And everybody thinks, oh, it's really rigid, it's really blah, blah, blah. It's the most creative discipline on the planet too. So knowledge graphs, you can create a knowledge graph out of anything. You could create I think there's a demo at 3 o'clock that talks about, shows the knowledge graph for YYC data. And it's a really, really great visual. Ours is very elementary, shall we say. But a knowledge graph is just simply a way of connecting two objects with a thing. And we actually, the edges, one of the constraints we put on it, I know I'm running over time. Is there another speaker right behind me?
Yes.
Okay, I have to go. Thank you very much.